This meeting is being recorded.
All right, hello. So this is our review. I'm going to share my screen. So that we can go over the review. At any moment you have questions, again, feel free to ask. Okay, so your exam, you have a week to complete it from Tuesday, and it's multiple choice, completely multiple choice. A, B, C, D. I think there's 4 options in the multiple choice, yeah. So let's go over your review. Now, I broke it down from section to section so that you can go back to the section in case something seems funny. You can access this on your module, specifically that page where I talk about us having a Zoom meeting. You have that, you have this review, you have the key to this review. So in case you don't want to write down, you just want to follow along, you can see the key. And I also include a page with calculator commands so you can work your way through this review. All right. So our first question reads from section 4.1. In 2004 baseball season, Ishiro Suzuki of the Seattle Mariners set the record for the most hits in a season with a total of 262 hits in the 262 hits. In the following probability distribution, the random variable x represents the number of hits Ishiro obtained in a game. A, verify this is a discrete probability distribution. All right, for something to be a probability distribution, everything, well, it needs to be these 2 things. First, the sum must be 1. So that means you have to add them up, whether it's giving as a decimal or as a fraction, hint, hint, fraction, you have to add them all up. Your answer should be 1. If it's not 1, then you would say no, it's not a probability distribution. So what you do, we add them. 2, every probability needs to be between 0 and 1. Meaning you can't have any negatives, you can't have a probability that's bigger than 1 or 100%. So what does this mean? We have to add them all up and make sure they equal 1. And sure enough, if you crack your calculator and you punch them in, your answer is 1. B, you want to compute and interpret the mean and standard deviation of a random variable x. So for this particular problem, having your calculator is what's gonna be helpful. So make sure you have your calculator out. And if you don't have it, you can use Excel. So what we're gonna do is we want to look for probabilities. We want to find the mean and standard deviation. If you're using a calculator, you want to enter this as L1 and enter your second list as L2. And you want to bring up those commands as usual. You want to do, just so you would do L1, you want to do stat scroll over to calc, press enter, and then bring up L1 and L2. So you want to enter L1 and then put a comma. I see an often an error is that we don't put that comma, and then L2. And then it'll give you your 1 bar stats, your 1 variable statistics. With that, you'll get your mean and your standard deviation. You don't want to do this by hand. It's a lot of steps. If you use Excel, you can Google it, how to do it. I think you can go back to chapter 3 where we talk about how to do weighted means. So your mean, your X bar is 1.6273, and your standard deviation is 1.178. Now, C, what's the probability that in a random selected game, Ishiro got 2 hits? Well, what's the probability of getting 2 hits? 0.2857. And that's just from looking at your chart. So that's 4.1. 4.2. 4.2 is tricky, right? It's tricky because of the wording you might use. So let's take a look at section 4.2, question number 2 on your review. 34% of US adults have very little confidence in newspaper. You randomly select 8 US adults. Find the probability that the number of US adults who have very little confidence in the newspaper is. So you have exactly 6. So your probability is equal to 6. Your probability is at least 4. So for at least 4, we want 4 to be the smallest number. Less than 5, you want the probability of it being less than 5. So just as a command. Now, I understand the wording is different. It's odd. I will share with you a little chart with wordings and how to assign an equality to it. I'll add it to your review Zoom page. So I'll make a note to myself. Add wording chart. Okay. Now, for the first one, it's not so bad. We want to see what's the probability of having 6. Okay, well, we want to find what is our total, our n. Our n is 8. In general, we'll be using that. Our total amount is 8. And our probability, we have 34%. We want to change in decimal form, so that'll be 0.34. Okay, now we're going to use this knowledge and enter into our calculator or Excel. Depends what you're working with. So for a calculator, you want to press second command and then bars. The second button and then bars. And you want to scroll all the way to the bottom until you see binom PDF. On my calculator, it's the 0 option. That's for binomial probability distribution, right? So we want exactly 6. Our command would be binom PDF. And then we're going to enter, on our binomial probability distribution, we enter our total, our size, and then, no, our percent, then our size. And then our x, what we're trying to work with. So we have probability distribution of n, which is 8. Our percent is 0.34. And then we want exactly 6. We enter that in our calculator, and we should get 0.0188. Now, this binomial PDF is very helpful when you want just a probability of one number. Now, right underneath binom PDF, you have another command, which is super helpful as well. Binom CDF. So binom CDF is a cumulative addition. It adds them from 0 to your number that you want to stop with. You have to tell it what number you want to stop with. Now there's at least 4. If you ever get caught up on the wording, you can always do a number line. So if I have a number line and I want 4, and I want x to be greater than 4, but I also want to include 4. So that means I want numbers like 4, 5, all the way until I get to 8. I want all of those numbers. So what we could do, that I don't recommend you do, is you can do a binomial PDF for 4, 5, 6, 7, 8, 8 and stop, and then add them all up. It's a lot of work. However, we can use 2 tricks. We can take the binom CDF, that cumulative addition that it has, and use our rule of complements. So how about we find the addition from 0 through 3. So we can, in return, ask our calculator for binom CDF. Notice the C, not the, it doesn't say P. And we're going to enter our same pieces, but we're going to tell it to stop at 3. So we enter our n of 8, our percent is 0.34, and we're going to stop at 3. So that's going to give us our sum from 0 to 3. So it's going to take the probability of 1, probability of 2, probability of 3, and add them up. Now, we don't want 0 to 3. We want 4 and on. So what we're going to do is do 1 minus. So do 1 minus. And you can enter it in your calculator in one shot. Do 1 minus binomial CDF, and your answer will be 0.27. 0.2724. All right, now that less than 5. If you ever get caught up on it, I always recommend you draw a number line. So I want numbers less than 5. Numbers less than 5, well, those are to the left of 5. Because I don't have an equal to, I don't want to include 5. So what numbers do I want? I want numbers like 4, 3, 2, 1, and 0. Those are the numbers I want. So if I want the numbers from 0 to 4, well, I can use a cumulative. Now, the one trick to remember about the cumulative command is that it adds them from 0 and on. So it doesn't add them from a stopping number and above. So for this one, we can just use the binom CDF. So we do binom CDF of our n. Our total amount is 8. My percent is 34. And we want to stop at 4. So it's going to find that sum. Our answer is 0.90506. Now, I know these are tricky. When I've had students show up in office hours, these are the questions that are giving you those headaches, right? Email me your questions. I'm happy to help. I know that wording is tricky. All right, chapter 5 it's really fun. So chapter 5 all goes based on the idea that it's approximately normal. So we have this bell-shaped distribution. What's important to remember about your bell-shaped distribution is that at the very middle, we have our mean. And based on our mean, we can say what the percent falls if we have our standard deviation in our mean, right? Okay, so for 5.1, I have some little preliminary questions. So number 3, in normal distribution, which is greater, the mean or the median? And explain. Well, in a normal distribution, Ideally, if it's approximately normal, then our mean and our median would kind of be the same, right? They're all fall in the middle. Now, number 4 is an important one. So what is the area under the curve? So what makes this so cool about this, what we're doing, is that we're kind of doing calculus, but we're using different techniques so that we can go around that. Now, we want to find the area under the curve, but we're working with probabilities. Now take a look at that first question. What must be true for a probability distribution? We said the sum has to be 1. So we go and answer this question, what's the area under the curve? It equals 100%. It equals 1. So our mean, which is in the middle, that's 50%. And we can kind of use it as a guide to know if we're on the right or wrong track. Is it less than or more than 50%? Now for the remainder of your questions, I highly, highly suggest you that you draw your work. That would make it very helpful for me so that or mainly for you, make it really helpful for you so that you can see what you're working with. All right, we're working with question 5. It's telling us to find the area of the standard normal curve, and it's giving us a z-score of 0.17. B is giving us to the right of the z-score of 1.485, and C is between the z-scores of negative 1.55 and a z-score of 155. So I'll ask you a question. What is a z-score? Well, remember, a z-score is just the number of standard deviations. So we're saying that everything, we want to find how the probability of it being within certain amount of standard deviations. Z-score is standard deviations. Now, we started working with the bell-shaped curve, right? For that, you're going to need the mean. Do we have the mean? No. Whenever you're given information, and like this one where you don't have anything other than the z-score, we assume that we have a mean of 0 and a standard deviation of 1. So for these problems, we have a z-score of 0.17. Our command for binomial or normal distribution is second button bars, and then it's that second option, normal C, D, F. So this is your command pretty much for the remainder of your portion of your exam. Okay, so we want to find a probability of being left of 0.17. Well, I guess we don't have to really draw it. To the left of 0.17, yeah, let's draw it. We have a mean, and we want those that are left of 0.17. 0 is, a z-score of 0 is our mean. So then we want something like this from the left and on. When we're entering these commands on our calculator, we want an upper bound, a lower bound, an upper bound, I said that backwards, a lower bound, a lower bound, an upper bound, a mean, and a standard deviation. That's what we enter every time for these type of problems. So for this problem, we want normal CDF, and we see it technically goes on forever and ever and ever. Theoretically, we understand that it doesn't. So what can it enter for a negative infinity? Well, we enter a really, really big negative number. It doesn't matter what it is. You can enter 1 and as many zeros as your finger would like to push. and they want to upper bound. Where are we stopping? Well, we're stopping at a z of 0.17. 0.17. And what is our mean? Our mean is 0. And what's our standard deviation? It's 1. So our answer is 0.5675. You get a lot more numbers, right? Okay, B. To the right of a z of 1.485. So we have our bell-shaped curve. You want those that are right of 1 and whatever. We want the right. So we know theoretically it goes on to infinity, but it doesn't really. So you pick a really big positive number. So 1 and as many zeros as you like. You can punch in a bunch of 9s. It doesn't matter as long as it's a really, really big number. So our calculator, we enter normal CDF, and then we want your lower bound and our upper bound. So our lowest number we have is that z of 1.485. And we want a really big number. And then our mean is 0 and our standard deviation is 1. So our answer is 0.6877. All right, let's take a look at C. Now we want between negative. So think of this as number line. This is 0. To the left, you have a negative. To the right, you have a positives. You have negative 1.55. And then we have 1.55. We want the value in between. That's what we want. Okay, so I ask you, what is your lowest number and what's your highest number? What's your lower bound and your upper bound? So we have normal CDF. Our lower bound, negative 1.55. Our upper bound, 1.55. What is our mean? Well, it tells us that it's normal, so it's 0 and our standard deviation is 1. We enter that in our calculator and we get 0.8789. Now for these type of problems, you can just punch them into your Excel. I think I gave you a page on week, I think 6 or 7, where I show you how to do it in Excel and your calculator. Calculator is more fresher in my mind than Excel. Excel, I forget all the time. All right, section 5.2. Just like the other problems we just did, we have the same applications, just different numbers. So for this problem, number 6 in section 5.2, steel rods are manufactured with the mean length of 25 centimeters. Because of variability in the manufacturing process, the length of rods are approximately normally distributed with a standard deviation of 0.07. Okay, so it gave me a really big piece of information. It gave us the mean and our standard deviation. I need to use that when I try to answer my question. So let's read question A. What proportion of the rods are shorter than 224.9? Okay, actually, give me a moment. Let me make this file larger. So take a quick 2-minute break. Alrighty, let's come back from our little mini break. So I give you guys, give myself more room to properly explain it so I wasn't so crunched. So what's important to notice about this question is our mean. So our mean is 25 and our standard deviation is 0.07 centimeters. So it's telling us that it's approximately normal, and that's important because that allows us to use our bell shape. Okay, so we have our bell shape and we have our mean of 25 centimeters. And we know that we have that standard deviation of 0.07. So what proportion of the rods are shorter than 24.9? So 24.9 is a bit smaller than 25. We want them, those that are shorter, right? Smaller, so we want to the left. So we know that technically they go on forever and ever to the smallest number, but they technically don't, right? They stop. So we want to find that probability. Well, we're going to use normal CDF. And you need your upper, you always enter this. So let me write your skeleton. It's always your upper bound, your lower bound, your mean, and your standard deviation. That's always what you enter. Now in this case, we're going to enter normal CDF. And I wrote that backwards. It's lower and upper. So in this one, what is your lowest number? You read from left to right, we read our math from left to right. So we see that our smallest number is negative infinity. So we enter a really big negative number. It doesn't matter what it is. And then where do we stop? Well, we're seeing that we're stopping at 24.9. So we enter 24.9. And then we're left to ask ourselves, do we have a mean? Do we have a standard deviation? Our mean is 25. And our standard deviation is 0.07, and that was given. We enter into our calculator, and you get your answer. So our answer was 0.0766. All right, next question. B, any rods that are shorter than 24.85 or longer than 25.15 are discarded. What proportion of the rods will be discarded? All right, well, let's take a moment to digest this and let's draw a picture. So if we draw a picture, our mean hasn't changed, it's 25, and we have a standard deviation of 0.07. So the ones that are shorter than 24.85, 24.85, and longer than 25.15 are discarded. So this is what we want, right? Those two ends. So you can be clever and use this however you like. You can do the left part and then do the right part and add them. Or we can be crazy and find the middle part only. And then all of this is a probability, right? So we can then subtract it from 1. Let's do that crazy one. So our whole probability of everything is 1. We want to subtract just that middle part because I want everything else. We want the outer ends. So we want 1 minus, we enter our normal CDF command. Now it's important to remember your lower and your upper. What is your lowest number in your probability? Is it negative infinity? No, right? This time our lowest number is actually a number we're working with. We want 24.85 as our lowest number. And what is our upper number? Our highest number is 25.15. And then we want our mean and a standard deviation. Our mean is 25 and our standard deviation is 0.07. And there we have it. So our answer for this question is, it's about, after we round, 0.0321. Number 7, the mean incubation time of fertilized eggs kept at 100.5 degrees Fahrenheit in a still air incubator is 21 days. Suppose the incubation times are approximately normally distributed with a standard deviation of 1 day. A, determine the 17th percentile for incubation time of fertilized chicken eggs. Okay, well, for this problem, very similar type of question, but kind of backwards. So to begin, where it's saying 17th percentile, it's kind of giving you what we want as an answer. Well, based on the question before, it's telling us that we want to find out that 17th percent mark. That's what we're looking for. So if I have my bell-shaped curve, and based on our question, it's telling us that the mean is 100.5 and a standard deviation, and a standard deviation of 1 day. Okay, so our mean is 100.5. We want to find out that 17th percent mark, that 17th percentile. So when you want to find, given the percent, find that number associated with that percent, we're going to use a different command. We're going to use inverse norm, your inverse normal. So you're finding the opposite of your normal distribution. To find in norm, you press your second button and your bars. And then you scroll down. For mine, it's right under normal CDF. So it's that third one. All right. For that, we enter our percent, our mean, and our standard deviation. So for us here, our percent would be that 17%. So we enter 0.17. Remember, we always take our percent and then use it as a decimal when we calculate it. Then we enter our mean. Actually, I labeled my mean incorrectly. My mean is 21 days. My mean is 21, and then my standard deviation is 1 day. So what's that going to give us? That's going to give us the number associated with that percent. So it's going to give us the day associated with that percent. If we enter our calculator, it's 20.05. So out of 20 days, out of 21 days being our average with a standard deviation of 1, 20 days, 20.5 days is associated with that 17% mark, that 17th percentile. Okay, next question. Determine the incubation time that make up the middle 95% of fertilized chicken eggs. Okay, so let's draw it again. So we have our bell-shaped curve and we have our mean. We said our mean is 21 days with a standard deviation of 1 day. Now I want the middle 95. Now this one's tricky. Now we want to find the percent associated with this lowest mark and this highest mark. What percent is that? So to help you build your answer, all of this is 100%, right? From beginning to end. So if I take away 95%, I'm left with only 5%, right? 100 minus 95 is 5. So I have 5% to split between two tails. 5 divided by 2 gives me 2.5. So I have 2.5% here and 2.5% here. Now, if I want it as a percent, it's 2.5. But remember, we always want to work with decimals. So to change your decimal form, you just move it to the left twice. So we want 0.025. And then what is this mark here? I know this is 2.5, but this mark here, starting from 0 to that number, what is that mark? That's 97.5%. So we will write it as 0.975. So we're going to do inverse normal twice to find that lower half and that upper half. So we have inv norm 0.025 out of the mean of 21 and standard deviation of 1. And then again, inv norm of 0.975, 21 and 1. For the first one, our answer is 19.04. For the second one, it's about 22.96. So what makes up the middle, 95%? It's made up of anywhere between 19.4 days and 22.96 days. So that's where you get your 95% of your chicken eggs being hatched. 5.3. In a recent study on world happiness, participants are asked to evaluate their current lives on a scale from 0 to 10, where 0 represents the worst possible and 10 represents the best possible life, not life. The mean response was 5.4 with a standard deviation of 2.2. A. What response represents the 88th percentile? Okay, so this is just like our last example, right? So if we draw our bell-shaped curve, and we are given the mean of 5.4 and the standard deviation of 2.2. So we will label our mean 5.4. All right. So if I want to find the number associated with the 88th percent, I want to find that number that applies to that percent. So out of 0 to 10, 88%, what is that? Well, we do our inverse normal command. So we write our percent, 88% would be 0.88. Our mean is 5.4, and our standard deviation, we're told, is 2.2. So we have 7.98. So we can say that 88%, we have an 88% chance of someone saying 7.9% is their rate of life, of quality of life. And B and C are kind of the same type of question. So I'm going to skip those since we've done plenty of percentiles. I'm going to go to 5.4. Now, 5.4, you recall, what makes it so different from the rest of chapter 5. What makes it different is their sample size, right? So assuming that you have two things, that it's normal and you're given a relatively small sample size, you have to find technically the mean possible standard deviations of all those numbers. It all comes down to a new formula, right? So our formula for this section that we're going into is the average of your standard deviations is your standard deviation divided by the square root of n, where n is your sample. Question: how do you know when you have this type of situation versus the other one? Two things. You're going to be given a sample size. That's important. If the word sample size though is thrown in and you want to find the probability of something happening, giving a mean and standard deviation, this is your situation. Another thing is you're given a sample size that's particularly small, relatively small. So we have to find this new standard deviation to make up for that small sample size. Okay, so let's take a look at question 9. A simple random sample of size n equals 12 is obtained from a population with mu equals 64 and standard deviation equals 17. So we have our mean and our standard deviation. What must be true regarding the distribution of the population in order to use a normal model to compute probabilities involving the sample mean? Assume that the condition is true. Describe the sampling distribution of x. Okay, so according to this section and our central limit theorem, so it's something you can read from this section, is that things become, or your distribution becomes relatively normal as it gets bigger. Now, the thing it says is that you want sizes that are about 30 or larger in order for it to kind of become that normal shape. So if you look back at that section, it kind of shows you how, depending on your size, around 30, it's where it comes that prettier bell-shaped curve. So what must be true? Well, according to our central limit theorem, we want a size of about 30 or more. All right, B. Assuming the requirements described in part A are satisfied, determine the probability of x being less than 67.3. Okay. Well, it all comes down to our bell-shaped curve, right? So we have a mean. We were told our mean is 64, right? Yeah, 64. And our standard deviation is 17. Now, I want to find a probability of those being 67.3 or bigger. So it's a typical normal CDF question, right? So we want to find normal CDF. And we want our lower end. Our lower end goes on forever. So we pick a really negative big number. And then we're stopping our upper end. Our upper is 67.3. Our mean is 64. Now our standard deviation, that's what's different. I can't use that standard deviation that's given from the beginning of the question because it's telling me my sample size is 12. So I need to find that new standard deviation using our formula above. So we have, I'll write it for you again. It's sigma divided by square root of n. So our standard deviation given, we were told, is 17 divided by your sample size. Our sample size is 12. Now you have to go ahead and use your calculator, just punch this out. You have 17 divided by second square root of 12, we have 4.907477, and it continues on. We're calculating it. Use as many decimals as you like. I think the more, the better, the more precise answer you'll get. So our new standard deviation that we're going to use in our calculation is 4.91. And you punch it into your calculator, you get 0.7492. And that's it. The other question is very similar to what we did here, but it's kind of a mix of those two questions that we've done for chapter 5. I won't go over it because I don't want to make the Zoom meeting too long, but I do want to show you, let me stop sharing. I do want to show you that you have all of this in your Canvas course. So let me share my screen momentarily. And in your modules for this week, I'll post the Zoom recording here. So in case you're wondering you want to see this again, it'll be here. I'll post it right here. But I also have a key for your test 2. So everything we did, I already have for you in case you skip something or I went through something too quickly. You have everything there. And I try to be as neat as possible. Hopefully that makes sense. I did put that calculator note so you know how to use your calculator. And it has that same outline, your lower bound, comma, upper bound, comma, your mean, comma, your standard deviation. And just like here, I always draw that bell-shaped curve because that's so important. It helps you remember what you're working with and how you're doing it. And also have our last question that I didn't do live with you guys there too. So you can do it together or on your own. No, not stop share. I also included your a little outline of how to use your calculator just so you have it handy during your tests or just to have handy period. It shows you what commands you use so that you can punch it in properly. And I gave you a quick little explanation for it. All right, I'm gonna stop the recording.